All right, we're going to take another look at an optimization problem, an example. So we have a toy company manufacturing two types of toy vehicles, racing cars and sport utility vehicles. Because supplies are limited, no more than 40 racing cars and 60 sport utilities can be made in one day. So let's declare some variables first. Let x equal cars, y equal sport utilities. We're told that no more than 40 racing cars. So x is less than or equal to 40. Y is less than or equal to 60. The company can make 70 or more vehicles. So x plus y will be greater than or equal to 70. We're also told it costs $8 to make a racing car and $12 to make a sport utility. So that kind of gives us our production costs. Cost will equal 8x plus 12y, right? $8 for the racing car, $12 for the sport utility. So if we say each one of these squares is going to be 10, we label our axes, or we scale our axes. We also know that x has to be greater than or equal to 0. Y has to be greater than or equal to 0, right? We can't make negative cars. It's one of these real life examples. We also know that x will be a whole number, y will be a whole number, because we can't make half of a toy race car. So let's graph this. So x is less than or equal to 40, so our boundary line will be at 40. And it'll be a solid line because we have the equal sign under the inequality. And x is less than 40, so we shade in that area. It should be stippled, but we're not going to worry about that right now. Y is less than 60, so we draw our line at y is 60. We know that y is less than 60, so we shade that area. So far our solution space is this shaded area down here. Now we need to rearrange this equation right here to get y all by itself, right? Point, slope, form, and all of that fun stuff. So we're going to subtract x from both sides. So our y-intercept is going to be at 70. Our x-intercept will be at 70. So we can draw that line. So we have 3 points. Sorry, we have to do some shading. So let's take a test point 10, 10, right over here. So we plug that in. We'll move this, plug it in down here. So 10 plus 10 is greater than or equal to 70. 20 greater than or equal to 70. This is not the case, so this test point is not part of the solution space for our red line. So we're shading in this area here. So this triangle right here is our solution space. So we're looking for the maximum and the minimum cost. So we need to find out what all these points are. So the first one will be at 1060, 4030, and this point is at 4060. So let's plug those values in to our cost equation right here and see what we get. So the first one, we have 8 times 10 plus 12 times 60. So we have 80 plus 720 is equal to 800. So that day will, or that combination will cost 800. If we look at this one, we have 8 times 40 plus 12 times 30. So it's going to be 320 plus 360 is 680. And the last one, do down here, 8 times 40 plus 12 times 60. So that's 480 plus 720. It's going to be $1,200. So this point here is the least expensive day, and this point here is going to be the most expensive day.